Okay. Somebody hands us a closed interval and says, use the extreme value theorem and Fermat's theorem to find the absolute global max and global min on that interval. Here's what you're going to do. It's the same steps every time. Set the derivative equal to 0. Figure out any place where the derivative either doesn't exist or equals 0. Find your critical points. And then check your endpoints. Remember, globals can occur at endpoints. So critical points will never be your endpoints of your interval. They're not going to pop up. So we're going to check all of our critical points where the derivative doesn't exist or is 0. We're going to check our endpoints. Whoever's the biggest wins, whoever's the smallest wins. Let's do an example. Okay, so let's find, here's our function. Let's find our critical values. Points are points, so just the x values we call the critical values. So let's take his derivative. That'll be negative 2x plus 3. You should just be able to look at that. That guy's defined everywhere, so I don't have to worry about undefined. Critical values occur where the derivative equals 0 or is undefined. Don't forget about that one. But that's a line. It's always defined. So set the derivative equal to 0. So we get negative 3 equals negative 2x. X is 3/2. That's inside my interval. I only care about values inside this interval. If I get a critical point that's not even in this interval, who cares? We ignore it. If you get things that are not in your interval, we ignore them because we only care at this moment about stuff inside that interval. So that might be a global max, a local max, a global min, a local min. That could be any of them. I want to find the biggest value on this interval, so I have to check the critical values and the endpoints. Here's where mistakes happen. People forget to check the endpoints. So I'm literally just plugging all these values in. I want f of 1, f of 3, and that one we just found, f of 3/2. I can probably do these in my head. That's going to be negative 1 plus 3. So that would be 2 minus 2, I get 0. Plugging in 3, I'm going to get negative 9 plus 6 is negative 3. Minus 2, I think we get negative 5. You guys definitely check my arithmetic here. And then 3/2, I'm going to get the calculator out. Let me pause. Okay, so plugging in 3/2, so I want negative 3/2. I'm just going to call that 1.5 squared plus 3 times 1.5, 3/2, minus 2, 0.25. And so we know what this graph kind of looks like. It's an upside down parabola, right? We're only going from 1 to 3. I don't care about everything else. 1 to 3. At 1, we're at 0. At 3, we're at negative 5. And at 3/2, that's my vertex, we're at 0.25. So here's 1.5, and we're up here at 0.25. So my graph looks something like that on this closed interval. Okay, what's the biggest value I see anywhere on my screen? Right there. This is my global max. Also happens to be a local max. Critical points can be local maxes or mins. Endpoints are not allowed to be locals. So that guy right there and that guy right there, I would never call a local. Locals only happen at critical points. Okay, what's the smallest value I see anywhere? Right there. There's my global min. So when we're looking for global maxes and mins on a closed interval, we find all of our critical values, places where the derivative is 0 or undefined. We plug in our critical values and our endpoints into the original. Notice here, all of these I plugged into the original. If I were to plug these values back into the derivative, like here, I would just get 0. And then for these guys, I would get the slope of the tangent line there. I don't care about that. We're looking at actual y values. Okay, let's do another one. So my derivative here will be 2x minus, bring that down, 2/3 times 3 would be 2x to the negative 1/3. So that is 2x minus 2 over the cube root of x. This guy is undefined at 0. So f prime does not exist at x equals 0. You're not allowed to have, you can't take this of 0. So that's going to be a critical point. Now that happens to also be an endpoint, but that's okay. And then where does f prime equal 0? Now we'll do 2x minus 2 over, that's a cube root. Cube root of x equals 0. So like then we're going to get a weird answer here. Let's move that over. We get 2x equals 2 over cube root of x. I don't think we're getting anything interesting. Let me pause. Hold on. Okay, so yeah, I just wanted to make sure we were getting something. The 2's can cancel. I've got x equals 1 over cube root of x. I could multiply that over. Maybe it would be better to write that as x to the 1/3. So I'll have x to the first times x to the 1/3 equals 1. Like the answer should be kind of obvious now. That's 3/3 plus 1/3. That's x to the 4/3 equals 1. We actually get 2 values for that. This will actually be x's plus or minus 1. But I only care about x values inside my interval of interest. Who cares about that -1? Yeah, we're going to have a critical point at -1. It's not in my interval. Don't care. X equals 1. So I have 2 critical values. X equals 0 and x equals 1. And then I have my endpoints. Zero and 2. Right there. So I'm going to plug all of those in to the original function. F of 0, you should just be able to see that 0. F of 1 will be 1 minus 3, that's -2. F of 2 will be 4 minus 3 times 2 to the 2/3 power. That'd be cube root of 2 squared, which is cube root of 4. Now I'm going to get my calculator out and see if that is bigger or smaller than what did I get here? -2. So I could even type it in like that if I wanted. 4 minus 3 times 2 to the 2/3 power, 2 raised to the 2/3, negative 0.7-ish. That's not my smallest value overall. -2 was my smallest value. My biggest value overall was 0. So that's going to be my global max. That's going to be my global min. Now, this one's kind of weird. Even though this was a critical point here, it is a place where the graph, if we were to graph this out, we'll get some high point right there. So if we were to look at the entire function, that would be a local max also. But on this closed interval, I'm only looking at these values here from 0 to 2. That's an endpoint. None of this over here even exists. Endpoints are not allowed to be called locals. So we would not, in this case, call that a local max because it's at the end of the interval. Endpoints are not locals. If we were to look at this thing over its entire domain, we would call that a local because he would be higher than points on the left and the right. Okay, here we'll do this one more video. I think this is our last example before the word problems. Okay, so we want to find the critical values. That's places where the derivative does not exist, equals 0, that's a 0, or does not exist. Okay, so what do we got here? Take the derivative, we're going to get 1 minus cosine, or plus, sorry, 1 plus cosine of x. That always exists, so that's not going to happen. Where does this equal 0? Where does cosine of x equal -1? That happens an infinite number of times. If this is 2 pi, that's pi. Back here at -pi, back here at -3 pi, up here at +3 pi. Cosine equals -1 an infinite number of times. Don't care about all those. Only care about the ones in this region right here. From 0 to 2 pi. Only care from here to here. I'm on this closed interval. That only happens once at x equals pi. So that was the derivative there. That's not the original function. I didn't graph this. The derivative equals 0 at pi. So now I have to check y at the critical values I found. I only found 1, and the endpoints. Don't forget to check the endpoints. So I'm plugging in x equals 0 into the original. I'll get y equals 0 plus sine of 0. Sine of 0 you should know is 0. I just get 0. I plug in pi into the original. I'm going to get y equals pi plus sine of pi. If you don't know like your unit circle, if you don't have that memorized, I like to use the graphs for all the pi's, the pi over 2's, all the 0's and 1's. Here's the graph of sine. Here's 2 pi. Here's pi. Here's pi over 2. Sine of pi over 2 would be 1. Sine of 3 pi over 2 would be -1. Sine of pi is 0. So that's 0. I get pi plus 0. I get pi. Y at my endpoint, 2 pi. Will be 2 pi plus sine of 2 pi. Sine of 2 pi, also 0. It's right there. I get 2 pi. Okay, so what's my absolute max? What's the biggest value I have anywhere? Right there. There's my absolute or global max. What's my absolute or global min? Right there. I'm going to write global instead of absolute just to show you that they mean the same. There is the global or absolute min. It happens at x equals 0, has a y value of 0. Stop this one.